Okay, so this is Chapter 8 review, Algebra 2. So the first question is asked, question number 11, they want us to graph some of these rational functions, see if there's any intersects, asymptotes from the graph. So here we have y equals 1 over x for number 11. This is a rational function. At this point, x is on the bottom. X is the higher order degree. That means that we have a horizontal asymptote at 0. There's nothing being added or subtracted from the x. Therefore, there is going to be a vertical asymptote also at 0. So when we graph this asymptote, or graph this graph, the asymptotes are the x and y axis, doesn't cross the y-axis anywhere, or the x-axis, and that would be our graph. Here, for number 12, y equals negative 2 over x, since it's an x squared function, it's either going to both go up in this direction, both aiming towards up, or both going down. Since there's a negative in front of that 2, that flips the graph over the x-axis and it goes down. And this gives us an asymptote at 0 horizontally and a vertical asymptote at 0 as well. No x or y intercept are crossed. Here we have y equals negative 1x minus 4 for number 13. That minus 4 drops our rational graph down by 4. Since it's a negative in front, if we look at our original rational, it was in the quadrant number 1 and quadrant number 3. That gets flipped, and it's now in quadrant number, well, it's occupying both quadrants, 2 and 3, and in quadrant number 4. We have a vertical asymptote at 0, and we have a horizontal asymptote at negative 4, and it crosses the x-intercept at negative 0.25. Number 14, we have a rational function with a couple of things going on. It's going down on the y-axis by 1, and it's going to the left. This plus 3 means it's going to the left by 3 units. So our rational function shifts to the left 3, shifts down 1, and that is our graph. We have a y-intercept at negative 1, 0. I'm sorry, x-intercept at negative 1, 0, and a y-intercept at 0, negative 1/3. We have a vertical asymptote at negative 3, and a horizontal asymptote at negative 1. Okay. 15 through 16, we have this base pairing equation at y equals 4 over x, and they want us to, given the coordinates, write the asymptotes for the, or given the asymptotes, write the equation for this graph. So here we have an asymptote at 0. That means that the x stays the same, and we have a asymptote at y equals 3, so it's going to go up 3. So when we write this graph for number 15, it's going to be y equals 4 over x plus 3. For 16, we have a vertical asymptote at 2 and a horizontal asymptote at 2. So it's going to be y with 4x minus 2 in the denominator plus 2 in the outside of the rational equation. Number 17, we have x equals negative 3 and y equals negative 4. So negative 3 turns into a minus 3, which is a positive 3. So we have a plus 3, 4 over x plus 3. And since it's going down 4 units, it's going to be subtracted by 4. 18, we have an x equals 4 and a y equals negative 3 for our asymptotes. So when we graph it, it's going to be y equals 4 over x minus 4. And since it's a minus 3, we subtract it all by 3. All right, so for number 19, 20, and 21, they want us to graph and see if there's any discontinuities anywhere. So for 19, if you notice, We have an x minus 1 on the bottom. We have an x minus 1 on top. These guys can cancel out. When you can cancel out a bottom uh, expression with a top expression, this is a signal that it's going to be a hole, and we're going to have a hole at 1. So we have a hole at 1. If I was to use FOIL and multiply this out, this would have an exponent of x to the second power. This is a degree of x to the first. So that means that since x is to the second power, it's a higher order degree in the denominator. That means that we have a horizontal asymptote at 0. Horizontal asymptote at 0. After we simplify this and cross out the x minus 1, we're left with 1 over x plus 2, or 1 over x minus negative 2. And that gives us a vertical asymptote at 2. So vertical asymptote at 2, horizontal asymptote at 0. We have a hole at 1. And that is what we'll do for our graphs. What x cannot equal? Before we simplify this rational function, we have to see what x can't equal. X can't equal negative 2, because that would turn the denominator to 0, and x can't equal 1, because that would turn the denominator into 0. Okay. For 20, we have a graph that you're not going to see on any type of test, but it would be a diagonal asymptote, and the slope would be a slope of 1. Here, this x minus 2, we could turn it into x minus 1, x plus 1 as we separate it out, and that gives us negative 1 and positive 1 as things that x can't equal. We have a vertical asymptote at negative 1. There is no horizontal asymptote. And we have a hole at 1. Okay. Number 21, since it's a x squared plus 2, there is nothing that can turn the denominator to 0, so we have no points of discontinuity. So, but we do have a horizontal asymptote at 2, and it would look like that. Most of the graphs that you'll be seeing on any type of test is going to look in this format, so I wouldn't worry too much about 20 and 21. Maybe 21, but not so much 20. Okay. All right, so we're going to simplify these expressions. So we have up here for 23, looking at the right, we have x squared plus 10x plus 25. We have x squared plus 9x plus 20 at the bottom. I will factor these out, and I have x plus 5 times x plus 5 on top, x plus 4 times x plus 5 on top. At this point, this is the point before I cross out any expressions to look for any things what x cannot be. X can't be negative 4, x can't be negative 5. So we're going to put that in our Rolodex over here. X can't be negative 4 or 5. We cross out x plus 5 on top and bottom, and that leaves us with x plus 5 over x plus 4. This is our simplified version. X plus 5 over x plus 4, where x cannot be negative 5 or negative 4. For 24, we have x squared minus 2x minus 24 over x squared plus 7x plus 12 times x squared minus 1 over x minus 6. We're going to factor the left-hand side and factor the numerator up here. So this gets factored, this gets factored, and this gets factored. And that turns into x minus 6 times x plus 4 over x plus 3 plus x plus 4 times x minus 1, x plus 1 over x minus 6. At this point, before I do any cross-canceling or simplifying, I see the bottom 3 denominators and see what x can't be. X can't be negative 3, x can't be negative 4, x can't be 6. Negative 3, negative 4, and 6. I can cross-cancel x minus 6 with this x minus 6 up here. I can cross-cancel this x plus 4 with this x plus 4 down here. And I'm left with x plus 1 minus 1x times x plus 1, or x minus 1 squared, over x plus 3. All right. 4x squared minus 2x over x squared plus 5x plus 4 divided by 2x over x squared plus 2x plus 1. Uh, Again, factoring everything out. So here I can factor out a 2x. The denominator over here turns into x plus 1 times x plus 4. On the right hand side, the denominator can turn into x plus 1 and x plus 1. At this point, I look at the denominators and see what it can't be. And right now, x can't be negative 1, x can't be negative 4. If I'm dividing by a fraction, then I'm multiplying by its reciprocal. So I'm going to flip this over, and now the 2x goes in the bottom, and the x plus 1 and the x plus 1 goes up top. At this point, I look and see if there's anything else that x can not be, so that it cancels out. And in this case, with the 2x, x can also not be 0. So I have x not being negative 1, x not being negative 4, and x cannot be 0. I look to see if there's anything I could cross out. I can cross out this 2x and that 2x, this x over 1 and this x over 1. So I'm left with 2x minus 1 over x and times x plus 1 over x over 4, where x cannot be 0, negative 1, and negative 4. So for 27, we're adding and subtracting rational fractions. So we have 3x over x. This says x squared minus 4, so I simplified it ahead of time. X plus 2 times x minus 2. Over here, it's going to be 6x plus 2. So what I did over here, to make the denominators the same, I multiplied top and bottom by x minus 2. Here, on the right, it was 6x plus 2. I multiplied here top and bottom by x minus 2, so that I can have the denominators be the same. Once the denominators are the same, then I can add the numerator together. So that'd be 3x plus 6x minus 12. 3x plus 6x is 9x. So I have 9x minus 12. I can factor out a 3. And that gives me 3x minus 3 times the difference of 3x and 4. And that's it. What x can't be? Plus or negative 2. Here for 28, I have 1 over x squared minus 1 minus 2 over x squared plus 3x. Same thing. I can factor out this x squared, x minus 1, and make it be x plus 1, x minus 1. I can factor out an x here and call this x plus 3, times x plus 3, rather. At this point, on the right-hand side, or left-hand side, I'm multiplying top and bottom by x times x plus 3. On the right-hand side, I'm multiplying top and bottom by x minus 1, x plus 1. And that's what I do over here. And go through all the math. Here I got x minus 1 squared times x squared plus 3x. On the left-hand side, see, that's being multiplied by 1. So I get x squared plus 3x on the left-hand side. On the right-hand side, all that's being multiplied by 2. So I get 2x squared minus 2. I distribute that negative, and that's x squared plus 3x minus 2x squared plus 2 over x minus 1 squared times x squared plus 3x. At this point, x can't equal a few things. I go back here and I factor out. X can't equal 0, x can't equal negative 3, x can't equal negative 1, x can't equal 1, and I wrote those down here. The negative 2x and the x turns into negative x. 3x is by itself, 2 is by itself. So I get negative x plus 3x plus 2 over x times x minus 1 times x plus 1 times x plus 3. And x can't equal those 4 terms. 29, we are dividing complex fractions. I have an x in this denominator here. Looking at 29, I have an x in this denominator here, so I can multiply top and bottom by x, which is what I do on this side. The x distributes, this x and that x cancels, and that turns into 2x, so I have 2x minus the x cancels. So this would be minus 2. I have 3x minus in the bottom. The x will cancel, and I have 3x. And that turns into 1. So on the top, I have 2x minus 2, 3x minus 1. And then I can factor out a 2, and I'm done. For number 30, I have 1 over x plus y equals 4. So in this case, the denominator here is 4. So I'm going to multiply, to get rid of this 4, top and bottom by 1 over 4. 1 over 4 down here, 1 over 4 up here. This crosses out, and I get 1 in the denominator. It goes away. This 1 times 1 is 1 in the numerator, and I distribute the 4 across, or 4 times xy, and I am done. Okay. Solving for the variable. Okay, so for this one, I have 1 over x equals x minus 4. 1 over x equals 5 over x minus 4. I'm going to multiply both sides by the common denominator. The common denominator is going to be x times x minus 4. Whatever is the two terms in the denominator is what I'm multiplying top and bottom by. So if I look at the left-hand side, I have 1 over x. I multiply 1 times x minus 4 times x. The x and the x on the top and bottom cancels, and I'm just left with x minus 4. On the right-hand side, I'm multiplying also by x minus 4 times x. The x minus 4 over here cancels out with the x minus 4 down here, and I'm left with just x. So I have x minus 4 equals 5x. I subtract both sides by x, divide both sides by 4, and I get x is equal to negative 1. You have to check these because we could have extraneous answers that doesn't make any sense. So we plug in negative 1, and I have that it checks out just fine. For number 32, I have 2 over x plus 3 minus 1 over x equals negative 6 over x plus times x plus 3. Again, we have a common denominator, and the common denominator is going to be x times x plus 3 times x. Yeah, so it's just going to be x times x plus 3 as our common denominator across the board. So looking over here, I multiplied top and bottom by x plus 3 times x. The x plus 3 and x plus 3 cancels out right here, and I'm just left with 2 times x. I multiply 1 times x plus 3 times x, and the x cancels, and I'm just left with x plus 3 up there. And on the other side, the x plus 3 times x cancels on top and bottom, and I'm left with negative 6. So then it's renamed to 2x minus 3 equals negative 6. Combine the x's, I have x, add the 3 to both sides, x equals negative 3. I check to see if this works. I plug in negative 3 and I get a 0. We can't divide by 0, so that means we have no solution, y'all. Does not work. For number 33, I have 1/2 plus x over 6 equals 18 over x. I'm going to multiply everything times all the denominators. So 2 times 6 times x, so that's 12x. So 12x top and bottom. The 2 divides into the 12, gives me 6. The x stays. Here, 12x times x is 12x squared divided by 6, so this turns into 2x squared. Here, the x cancels, and I have 12 times 18. So that gives me 6x plus 2x squared equals 216. I subtract the 216. I factor out a 2, and I get the x squared plus 3x minus 108 equals 0. I can factor that into x minus 9 times x plus 12 equals 0. So I have two answers, either 9 or negative 12, and I check them both. I plug in 9. For x. And it works, and I plug in negative 12 for x, and it seems to work. See, now it works. Yeah, so it works. Okay. So the last problem says I travel 10 miles on your motorcycle, and the same amount of time your friend travels uh, 2 miles slower to travel 8 miles. How far did the person go? Or what's the rate of both of you guys? So this is a distance equals rate times time. D equals RT. What we have that's the same is it says it takes the same amount of time. So I'm going to rename this equation. I have D1 equals R1 times T. I have D2 equals R2 times T. The reason why I have D1 and D2 is because he traveled 8 miles, you traveled 10 miles. The rate's going to be different, but the time is going to be the same. So I'm going to do everything in terms of time. So I'm going to divide both sides by R. So T equals D1 divided by R1. T equals D2 divided by R2. I set those two guys equal to each other. D1, so if T equals T, then D1 over R1 equals D2 over R2. We are looking for rate. We don't know what R is. We do know that one is going to be 2 miles less than the other. So we can call R1 X, and we can call R2 X minus 2 because it's 2 miles slower. We know that you travel 10 miles in that rate, and the other person traveled 8 miles at that rate. So we have 10 over x equals 8 over x minus 2. Multiply both sides by the common denominator, which is x times x minus 2. I multiply x times x minus 2. The x is crossed out, and I'm multiplying 10 times x minus 2, which gives me 10x minus 20. I do the same thing on the other side. The x minus 2 cancels, and that leaves me x times 8, which gives me 8x. I subtract 8x from both sides, add 20 to both sides, and I get 2x equals 20. Divided by 2, and I get x equals 10. So you traveled 10. Your friend traveled 2 miles less than that, so your friend traveled at 8 miles per hour while you traveled at 10. All right. This is the section. I hope you have a great rest of your day.